Arjun, we've talked so much about LLMs getting smarter, but it feels like they're still trapped, unable to connect to the real world beyond their training data. Why is that?
Exactly, Maya. Even the most sophisticated models are often constrained by their isolation from data. They can reason beautifully, but they can't act on specific real-time information or integrate with tools easily. The core problem is that historically, every new data source requires its own custom implementation. Imagine having to build a completely new, bespoke adapter every single time you want to connect a new printer or device to a computer.
So it's an M times N problem. If I have M models and N data sources, I'd need M times N bespoke connectors, which is completely unsustainable and difficult to scale.
That's precisely the challenge MCP addresses. As the source says, MCP addresses this challenge. It provides a universal, open standard for connecting AI systems with data sources, moving away from that M by N nightmare.
So instead of that exploding number of individual integrations, we're aiming for something much more efficient, like M plus N connections.
Exactly. It's about replacing fragmented integrations with a single protocol. Think of it like standardizing on a single type of universal electrical outlet. Now, every single device just needs one compatible plug. This analogy holds true for the ease of connection and reduced complexity. However, unlike physical outlets, MCP defines a software interface, meaning the plug is abstract code, not a tangible object you physically insert.
And every wall outlet can then support any device that adheres to that standard. That makes so much sense for simplifying and scaling AI applications.
MCP is fundamentally an open standard that enables developers to build secure, two-way connections. It defines exactly how AI applications, which they term clients, talk to external systems, which are the servers.
So the AI assistant like Claude would be the client, and my company's internal knowledge base or database would be an MCP server. Is that the basic setup?
Precisely. Developers can expose their data through MCP servers for systems like Google Drive, Postgres, or GitHub. And conversely, they can build AI applications, MCP clients, like Claude, that connect to these servers.
So if I'm a developer at a bank, I could expose internal financial data securely through an MCP server, and our internal Claude client could access and reason with it?
Yes, and a key accelerator here is that Claude 3.5 Sonnet is adept at quickly building MCP server implementations. This ability of the AI to generate code or configurations for server implementations, potentially from natural language descriptions of data sources or desired tools, significantly speeds up adoption.
This significantly simplifies adoption, as developers can leverage AI to accelerate the construction of integrations, rather than coding everything manually.
It's not just theoretical. Early adopters like Block and Apollo have integrated MCP into their systems. This allows them to connect AI to critical enterprise systems and development tools.
So this is actively being deployed to improve how AI works in practice, enabling more sophisticated and grounded AI applications right now.
This also avoids a common pitfall, the constant maintenance burden. Instead of maintaining separate connectors for each data source, MCP offers a single evolving interface.
So it's not just about easier initial setup, but also long-term sustainability and reducing technical debt for AI integration. That's a crucial benefit.
Now that we've seen why MCP is so essential to solve the N by M integration problem and finally connect AI to a vast world of data and tools, let's build a deeper intuition for what that universal connection truly entails.
Okay, I'm getting the why. It's about overcoming the AI's isolation. How does it make all these vastly different systems speak the same standardized language effectively?
Last scene, we established that MCP is an open source standard for connecting AI applications to external systems. We saw it solves the problem of isolated models. But what does that universal connection really feel like?
I'm imagining a complex tangle of specific wires being replaced by one universal port, but that's still quite an abstract picture in my head.
The best analogy is right here in the documentation. Think of MCP like a USB-C port for AI applications. Before USB-C, you had different cables for power, data, display, or charging for every device. And now, one USB-C cable can often do it all for many devices. So MCP is that single versatile connection for AI, conceptually speaking.
The analogy is exact in that it provides a standardized way to connect AI applications to external systems. Where it breaks is that MCP isn't a physical port. It's a software protocol defining communication rules, not hardware.
So the port is purely conceptual, a set of agreed-upon communication rules and structures, not something you physically plug in. It defines the language of interaction.
Through this conceptual port, AI can connect to diverse external systems, data sources like local files or databases, tools such as search engines or calculators, and even workflows like specialized prompts.
So an LLM could not only read my internal sales database for information, but also trigger an action like sending an automated email or performing a complex calculation?
Absolutely. With MCP, agents can access your Google Calendar and Notion, acting as a more personalized AI assistant. This is how an AI can truly evolve from a chatbot into a proactive, helpful agent.
This truly transforms AI from a text generation tool into a proactive agent capable of performing useful work and automating tasks across various digital contexts.
From a developer's perspective, a huge benefit is that MCP reduces development time and complexity when building or integrating with an AI application or agent. It simplifies the entire integration lifecycle.
And you'd have to rewrite those custom integrations for every AI model or platform you wanted to connect, multiplying the effort. This is exactly how it avoids that M times N explosion.
For the AI applications themselves, MCP provides access to an ecosystem of data sources, tools, and apps which will enhance capabilities significantly. This means models can retrieve accurate, real-time information, greatly reducing instances of hallucination by grounding their responses in external facts, rather than solely relying on internal training data.
Because they can actually look up precise, factual information from trusted sources or use accurate tools instead of relying solely on their training data or making things up.
Here's another great example of practical application from the site. AI models can create 3D designs on Blender and print them out using a 3D printer. This shows concrete actions, extending beyond just text generation.
This represents a significant advancement beyond simple chat interfaces, enabling AI to bridge the digital and physical worlds through well-defined, standardized actions and tools.
This broad ecosystem support is crucial. It means not just Anthropic, but also other AI clients like ChatGPT and various development tools are adopting it. This helps prevent vendor lock-in.
So it's truly an open standard, not just a proprietary solution. That's key for its widespread adoption and long-term viability, allowing many parties to contribute.
So MCP is that universal adapter letting AI access diverse data and tools, much like USB-C. Now let's peel back another layer and see the actual technical architecture that makes this powerful communication possible.
Okay, I understand the concept. How do these AI clients and MCP servers actually communicate under the hood using this protocol?
To enable this universal connection for AI, MCP follows a client-server architecture. This is a fundamental computing pattern. One party requests services and the other provides them.
So, an AI application acts as a client, and the external system, like my company's database, functions as the server. It's a familiar model in software.
Specifically, an MCP host, an AI application like Claude Code or Claude Desktop, establishes connections to one or more MCP servers. The host is the orchestrator, managing these multiple links.
So the AI itself running on my machine is the host, and it can juggle multiple connections simultaneously, perhaps one to my calendar and another to my internal file system.
MCP defines its communication through two layers. The most critical for understanding how AI interacts is the data layer, which defines the JSON-RPC-based protocol for all client-server communication. This means messages between the AI and external systems are structured as JSON-RPC 2.0 requests, responses, and notifications.
JSON-RPC? So it's essentially a remote procedure call mechanism, but using JSON for data exchange? How does it standardize what the AI can actually do with these servers?
Exactly. The core of this JSON-RPC protocol lies in its primitives, tools, resources, and prompts. Think of these as the fundamental verbs and nouns the AI and servers use to interact. For instance, tools are executable functions the AI can invoke, like a database query, sending an email, or generating a 3D design.
So if the AI wants to access my company's CRM, the CRM server would expose tools like search customer or create lead, and the AI would call these like functions?
Precisely. An MCP client, the AI, would first send a JSON-RPC request to the server, perhaps a tools/list method, to discover what tools for AI actions the CRM server offers and their required parameters. The server responds with a description of its available functions. Then, based on its task, the AI might send a tools/call request, specifying a tool like search customer and providing parameters such as a customer ID. The server executes it and returns the result in another JSON-RPC response.
That's a very clear exchange. So the AI client has a standard way to both discover capabilities and invoke them, rather than needing custom code for each interaction. That sounds much more robust than simply giving an LLM free rein with an API key.
Beyond active tools for AI actions, MCP also defines resources for context data. These are essentially passive data sources that the AI can read and incorporate into its understanding. Think of them as structured documents, database tables, or files that provide specific, factual information.
So if the AI needs to answer a question about our company's latest quarterly report, it wouldn't use a tool to change the report, but a resource to read it?
Exactly. An MCP server might expose a resource for the latest quarterly report. The AI client could then make a JSON-RPC request, perhaps a resources/get call, specifying which part of the context data it needs, maybe a summary or specific financial figures. The server would retrieve that data, ensuring the AI is working with the most current and accurate information.
This really helps address the hallucination problem then. The AI isn't guessing, it's retrieving verified information directly from a trusted source.
Finally, we have prompts for interaction templates. These allow servers to provide structured guidance to the AI, essentially telling it how to formulate its output or what information to focus on for a specific task. They're like predefined instruction sets.
So instead of the AI just generating free-form text, a server could provide a template for a meeting summary or a debug report, ensuring consistency and adherence to company standards?
Precisely. For example, a development tool server might offer specialized prompts for generating code in a particular style or debugging a specific type of error. The AI client could request and utilize these structured prompts to ensure its output aligns perfectly with the requirements of the task, making its assistance much more effective and predictable.
That's smart. It gives control back to the system developers to guide the AI's behavior and ensures quality and format for specific use cases.
It's critical to understand the scope, though. As the documentation states, MCP focuses solely on the protocol for context exchange. It does not dictate how AI applications use LLMs or manage the provided context. MCP provides the pipes and the language for information exchange, but the AI's internal reasoning process, how it chooses which tool to use, or how it integrates resource data into its mental model, is entirely up to the AI application itself.
So MCP is the standardized bridge, not the AI brain. It gives the AI access and methods, but the intelligence to utilize them is still within the LLM. It's a powerful framework, not a complete AI solution.
Ultimately, by standardizing these primitives, tools for action, resources for data, and prompts for guidance, MCP reduces development time and complexity when building or integrating with an AI application or agent. It simplifies what was once a labyrinth of custom connections into a clear, unified communication channel.
So, this well-defined mechanism is the technical core that lets us finally move past that M by N integration problem and truly unlock the potential of AI by connecting it to the real world.
Exactly. We've explored why MCP is needed, understood its USB-C for AI intuition, and now seen how its JSON-RPC primitives enable precise communication. You should now have a solid foundation to understand and explain MCP.
I feel like I could actually explain this to a teammate now. Thanks, Arjun.